Welcome to another episode where we are doing all about physical sciences. My name is Tobile Nkosi and we're doing all about acids and bases. I just want to thank Liberty once again for sponsoring the show. If you haven't done it yet, please download the Tenfold education app and send through all your questions. Make sure that you send the correct questions that go with the correct topic that we're doing. For example, today we're doing acids and bases and we will only be answering acids and bases. Make sure if you have any other questions that you want me to answer based on physical sciences, either being paper 1 or paper 2, please save it, and then when we start doing revision, you can send through all those questions. So in today's show, like I've said, we're doing all about acids and bases, and I've got some interesting questions that I want us to look at. I'm going to try go in, answer the question, but also go into teaching you why some of the things are like that. Remember, it is a very crucial time, and I really do want you guys to all get a level 7 for physical sciences because it is an interesting subject. So with acids and bases, I always tell my kids, you must tell yourself a story. And if you feel like you are getting confused with what is happening because this is being titrated, this is being diluted, you must always draw yourself a picture. So for an example, I'm going to give you maybe 2 or 3 scenarios before I start answering the question so that you're going to see where I'm getting this. For an example, they can tell you, we have a beaker, and in this beaker, we're adding a solution. It has a certain volume, it has a certain concentration. And then we are adding pellets that have, let's say, 8 grams, and this is the information given. So when you are reading, draw yourself a picture. Then you'll have your reaction. Number 2, they can tell you we have a beaker. Let's say we have a base in the beaker, and then it has a certain volume. We have a certain concentration. Remember, solid brackets mean concentration, and we are adding an acid into it. Then you'll have your acid, which has a volume, a certain concentration, and so forth. So as we're going to answer today, you're going to see, I'm going to be drawing a picture that makes you understand what we're doing. Now, the number 3, the third drawing that I'm going to draw is a very tricky one that most of you guys make a mistake at. Now, listen to what I'm going to be saying. The third drawing, they can give you something like this and say, Tobile is titrating, or she has a mixture. In this mixture, it's concentrated, has a certain concentration, but then she adds water to dilute it, and then it has a certain volume. From this one, Tobile pours out some of the solution. She takes some of the solution out. Let's say all of this I pour out, and I pour out a volume of, let's say, 10 cubic decimeters. So it means I'm only going to work with this. So when you are reading acids and bases, you must read what they are telling you. It's either they're going to tell you we have a solution, we are adding something into it, or they're going to tell you we have a base, we are putting in an acid, we are titrating. Remember, we're trying to neutralize something. And then they're going to tell you one of the unknowns. The third one, they're going to tell you, Tobile is mixing something, and she continues mixing it, and let's say it's in a 1-liter bottle. But she doesn't really need all of that, so she's going to pour some of it out and only use 500 milliliters. So even though you already know the concentration for the 1-liter bottle, make sure you only use the volume that Tobile is going to use for her reaction. Because most of you guys get confused with the terminologies of English when they say poured out or only uses this. So make sure that you don't get confused with those terminologies. As we answer these questions, I'm going to be drawing some pictures to make sure that you guys are understanding. So let's start with today's question. The first question that I have, so most acids and bases will be on question 7. So as you're preparing, you will start seeing this. So the first question that I have, oopsie daisy, why can't I move up? The first question that I have, it says the reaction between sulfuric acid, already we see we have an acid, and sodium hydroxide. Already when I see the OH, I know that is a base. Solution is investigated using the apparatus illustrated below. So now, it is very nice if your teacher had time to actually do the experiment for you, but if you did not actually get time to do this experiment, this is what we call, when we are titrating, we use a stand. We use a burette, we use a flask, and so forth. So we are able to measure the exact amount of volume that is required to neutralize the other one. We can also add in some indicators and stuff like that. But this is an apparatus that we use in a chemistry lab when we are working with acids and bases. So now, so it says the solution is investigated using the apparatus illustrated below. Now, just to add on something, in an exam, they can either give you this diagram and then ask you to fill in these missing words. For an example, they'll tell you, what is the structure? This is a burette. And then they can also ask you, okay, in the burette, what do we put in? Do we put in the acid or do we put in the base? Now, in the flask, we will put the base, but in the burette, we will put the acid. So make sure that you know how to read everything off the graph, and you know how to put in the words in the graph. And another interesting question I've actually seen when it comes to when they ask you about burette, they can actually ask you, what are some safety procedures that need to be followed when we are working with a burette? So now remember, you have to wear a coat, you must make sure that you've got some glasses, do not inhale the acid or the base, it might be dangerous, and make sure that you actually have a teacher who's working with you. So even though they ask you some safety measurements based on this, make sure that you get full marks, make sure that you know how to read the graph, and you know how to plot everything that's there. So now that we've looked at the graph, let's see what questions are about to come. So 7.1 says we must write down the name of the experimental procedure that is illustrated below. Now that one is fairly easy. This is 7.1. The experimental procedure when we're using a burette and all that stuff is titration. This is what we call it. We call it titration. Let's look at 7.2. They can even ask you to actually explain or define what titration is. So make sure you also know how to actually work around it. And that was only for 1 mark. And then 7.2 is going to ask us, what is the function of a burette? Now, this is the burette that we have in here. Now, I actually want to elaborate a little bit more in case you haven't done this with your teacher. I'm going to use my fingers. Let's say this is my burette and we have some acid and this burette is full. And as you're titrating, there's a little tap that you twist. As you're twisting, some of the acid goes into the beaker, which means the acid gets less and less and less and less and less. So if we had started the volume of the acid at 15 cubic decimeters, and then we use it, and all of a sudden we've got 10 cubic decimeters left, we know that 15 minus 10 is 5, meaning we've used a volume of 5. So the burette helps us to actually get the exact measurement of volume that is required for the acid to then neutralize the base. So that is then what a burette is used for. But now that is an explanation. Now, because the examiner is looking for the correct genre or language that we use in chemistry, this is then how you're going to write it. But this is then what a burette actually does. So the reason for a burette, it is to measure the exact volume of acid needed to reach endpoint. You can also say to neutralize the base. Endpoint, which is to neutralize the base. So once we've reached endpoint, we are then able to say how much volume was then actually used. Let's look at 7.3. So 7.3 says we must define an acid in terms of Arrhenius' theory. Now, something that they love in physics is that somebody has discovered something and everyone wants to be remembered. So when you have to define something, you have to define it in terms of what this theorist has said. A definition, whether it could be Arrhenius' theory, Newton's laws, or momentum, or whatever, it remains the same. A definition of something does not change. However, an explanation of something is based on your own discretion. If we can both say, Mbali, what is the weather outside? Mbali can say, yo, Tops, it's so hot and I could be freezing. She is explaining it based on what she understands or what she's feeling. But I'm also doing based on that. So there's no wrong or right answer when you are explaining something. When you are defining something, the examiner wants to see whether, number one, you've sat down and read. And now remember, guys, you cannot fail a definition because you were lazy to read. Now back on Arrhenius' theory. So in grade 12, we use Arrhenius' theory and we also use the Lowry-Brownstedt theory or the Brownstedt-Lowry. Depending on which textbook you're using, that's how they name the theory. You now need to tell us, what does this person say in terms of acids? Now remember, an acid actually donates an H plus, or it's a proton donor forming H3O plus. Or we can say, or let's say talk about a base. A base is then a H plus acceptor, or it forms OH minus in solution. So now we need to say, according to Arrhenius' theory, now they can ask you anyone. They can ask you Arrhenius' theory or the other one, and they can ask you to define it, or they can actually ask you to show an example. Or they can give you two examples and say, according to Arrhenius' theory, which of these two, A or B, actually proves Arrhenius' theory? So make sure you know how to work flexible around it. My best advice to you guys, make sure you understand it and you are not cramming what is happening. Because remember, examiners can be very slick and they like putting some hot sauce on everything. So they can ask it in any angle and make sure that you know how to answer it. So in 7.3 it says, define an acid in terms of Arrhenius' theory. Let me just change colors. So 7.3, Arrhenius says, acids produce hydrogen. They produce hydrogen ions. You can also put that in a bracket to say it's an H plus. Or we can say, remember, to say something is an acid in solution, we will have a high concentration of H3O plus, which is hydronium ions. Hydronium ions, and this is in solution. This is in solution. So let's look at 7.4. 7.4 is asking us, give a reason why sulfuric acid is regarded as a strong acid. Now, I want to take you back to grade 10. In grade 10, we learned about the properties of acids and bases. We said acids are strong because they're corrosive, they can eat through flesh and all that stuff. And then in grade 11, we were talking about something being strong or weak because it ionizes or dissociates completely. Now, when we talk about sulfuric acid, it is a strong acid because it does one of those. So it ionizes completely. And this is how, so this is only for 1 mark again. So let's answer this one. So with sulfuric acid, so I can say H2SO4. So you can write down the name or the molecular formula. It ionizes completely. It ionizes completely. That is then why it is regarded as a strong acid. Let me just move to another slide. Okay, let me just get another question. 7.5 says bromothiamyl blue. Now, when we are reading bromothiamyl blue, you need to already get something that's ringing in your head. It is an indicator. Remember, we use indicators to show us that endpoint has been reached. Remember, when we do titration, meaning we have an acid, we have a base, then we have to use an indicator that will then show us that endpoint has been reached. In grade 12, we use methyl orange, bromothiamyl blue, and phenolphthalein. Those are the 3 that we usually use. Bromothiamyl blue is the one that's now used here. So bromothiamyl blue is used and is as an indicator. So sometimes they're going to tell you which indicator, and they might even ask you to define indicator. So please go learn the definition of what are indicators. Now we must write down the color change that will take place in the Erlenmeyer flask on reaching the endpoint of titration. Now remember, when we're talking about indicators, it depends in the solution that they're in. Some indicators will change according to the pH range in which they're in, and whether we're using a strong acid, a strong base, a weak acid, or a weak base. Now let's read what we were given here. So we know in this diagram here, I have my acid in the beaker. I've got my base in the beaker, sorry. And then in my burette, I then have my acid. So I am pouring in my acid in droplets into my Erlenmeyer flask. Now, before I answer the question, I want to give you a little bit of some background according to bromothiamyl blue and then answer the question for you. So remember, when you talk about bromothiamyl blue, because I'm just thinking now they can ask it in any way or the other. Bromothiamyl blue, it is a type of an indicator. Now what happens? Bromothiamyl blue is blue in basic solutions. So if the solution is basic, so in base, let me write conditions rather, in basic conditions. If the solution is basic, the color then will be blue. However, it will turn green if it is in neutral conditions. And remember, when it is neutral, we then use the pH scale. We use the pH scale to show us that it's neutral. It will then, just as green, it will then turn yellow in acidic conditions. Now, in our burette, we have, in the Element flask, we have a base. In the burette, we have an acid. So it means it will then turn from blue to yellow, moving from basic conditions. Remember, it's a base in the Element flask. In the burette, we have an acid. It will then turn yellow because we are adding the acid in. So our question wanted us to give an indication, either blue to yellow, yellow to blue, or green to yellow. Now we know we are adding acid into the base, so it means it will then move from blue to yellow, from basic to acidic. Now remember, they say choose from the following. Do not choose anything other than this. Write only blue to yellow as it is. So we are choosing this one. So for 7.5, that is the answer that we're going to have. The question wanted us to write that, so blue to yellow. But in future, if they do give you something like this, you need to know all of these conditions. And unfortunately, my darlings, it would be good if you read through all the types of indicators and how they actually change in solutions, either being basic, neutral, or acidic. Because like I like saying, the examiners can ask you either one way or the other. For an example, they could have in this question tell you, it actually turned yellow. What does that mean? So then you had to say bromothermal blue means we moved from a basic to an acidic. So they can ask you either one way or the other. So make sure you know it. The only way to know this is if you actually sit down and read. So let's answer another question. So this question, it says, so now we're going to have to start doing some calculations. So we're telling us that during titration, a learner adds 25 cubic centimeters of NaOH of concentration to an Element flask. Like I like saying, I'm going to draw myself a picture. Just see what number we are at now. We're at number 7.6. So 7.6, we have a learner, and she's going to add NaOH in an Element flask. It has a volume of 25 cubic centimeters. It has a concentration of 0.1. Remember, concentration is mole per cubic decimeter. Let's continue reading. So she, with that concentration, the Element flask, and titrates the solution with sulfuric acid with that concentration. So now I'm going to just draw it in another color. So we are titrating it with sulfuric acid. So that is now H2SO4. Now we know that the sulfuric acid, we don't know what the volume is. They've given us the concentration, which is 0.1 mole per cubic decimeter. So now let's see what the question says. So this is the picture that I should have in my head of what actually happened or what is actually happening. So the balanced equation for the reaction takes place. If this was not balanced, you need to balance it. Something that is very important when we work with chemistry is mole ratios. So I've got a mole ratio of 2 is to 1. Now 7.6 says determine the volume. Ooh, they're looking for the volume of the sulfuric acid, which must be added to neutralize the NaOH in the flask completely, and that is for 4 marks. Something very crucial is mole ratio, so that is 2 is to 1. So now let's start answering. So this is the picture. I've got my base. I'm adding in some sulfuric acid. I don't know my volume. I'm going to add my moles here. I saw that for sulfuric acid, my mole was 1, whereas for my base, my mole was 2. Let me just write it out here, just in case somebody doesn't have it. Let's see what we have. So it's 2 NaOH and H2SO4, which is 1. So I can then say 2 NaOH, and I've got 1. Remember, if there is no number, it just means there's a 1, which is H2SO4. This is my base, this is my acid. Now remember, I can then use this formula. Concentration of my acid, the volume of my acid, all over the concentration of my base and the volume of my base, all equal to the moles of my acid over the moles of my base. Now, something that is very nice, now you just plug in all that's required. Let's see if we've got everything. We've got my volume, we've got concentration, we've got the number of moles. Where did I get the number of moles? From the equation that was given, mole ratio. They want us to calculate the volume of my sulfuric acid. I do have my concentration and my mole is 1:2. Now we're going to plug in. My A is for acid, that's sulfuric acid. Do I have my concentration? Yes, which is 0.1. Do I have my volume? Nope, that is what I'm looking for. Let's move down to my base. Do I have the concentration of my base? Yes, that's 0.1. Do I have my volume? That is 25 cubic centimeters for my volume. So I'm going to, let's divide it by 1,000 to get it to cubic decimeters. So I'm going to do this in my head. I'm just going to move my comma 3 times, 1, 2, 3. So I'm going to get 0.025, and that is now in cubic decimeters. So my volume will be 0.025 is all equal to the moles of my acid is 1 over the moles of my base, which is 2. And now it's just pure mathematics. I have one unknown, which is my VA. If I've got a fraction on this side and there's an equation sign, I have to then cross multiply. So 1 multiplied by 0.1 multiplied by 0.025. So I'm going to have 0.1 and 0.025. Anything multiplied by 1 remains itself. I'm going to multiply 2 with that. I'm going to have 2 multiplied by 0.1 and VA. I'm looking for VA, so I must divide both sides with what is bothering my VA. I'm going to divide this side by 2 and 0.1. What you do on this side, I must also do on this side, 0.1. This and this side is going to cancel, and then I need to now find my volume for my acid. I'm going to use my calculator. Let me see if I can move it there. Can we move it somewhere I can see? Okay, let's put it here. So I'm going to have a fraction, open bracket, 0.1. Close my bracket, I'm going to have 0.025. Close the bracket, come down. I've got 2 multiplied by 0.1. Let's see what I get there. Remember, we don't want it as a fraction, we want it as a decimal. I've got 0.0125. I'm going to write it exactly like that. 0.0125. Now this is DM3. But I can, if let's say, for example, you wanted it in cubic centimeters as how it was given it to us in cubic centimeters here, I'm just going to move my comma back 3 times, 1, 2, 3. So you could have also had 12.5, but cubic centimeters. Remember, you have to have an SI unit. The examiners want to see that you know that we are measuring something. So this is a story that we had. I had a basic solution in a flask. I added some sulfuric acid. I had one unknown. Doing this as titration, I was then able to use this formula right here. Now let's see if I can do another question. So let's look at number 7.7. Now they're telling us if the learner passes the endpoint, so we've reached endpoint, but we passed the endpoint by adding 5 cubic centimeters of the same sulfuric acid in excess, so there is more than what is required. Now we need to calculate the pH of the solution in the flask, and this is for 7 marks. Now guys, I just want to tell you something. Questions like this, most of the time, it requires the answer you got before so that you can use it in the answer or in this question coming here. If you made a mistake, say hypothetically speaking on number 7.6, and you got a volume that was not really correct, make sure you continue using that same volume in the next question. You can get marks for continuous assessment because you understood that, okay, now that I've got that volume, but we added more into that volume, it means I had to add. Then the examiner can say, okay, you understand the procedure because that's the important part. Yeah, we do make mistakes here now and then when we are multiplying, but the procedure that you are using is very, very crucial. So make sure whatever answer you got in the previous questions, you carry it over moving on, and then you are able to actually score some marks. So in this one, we have a learner who passes endpoint by adding 5 cubic centimeters of the same sulfuric acid in excess, but now we need to calculate the pH of the solution in the flask. So let's see how we're going to do that one. So we have the sulfuric acid, right? We had whatever volume we had there, and then we added another volume of 5 cubic centimeters, right? So now this means if I had, let me work here. If I had my sulfuric acid, which was H2SO4, this means, okay, let me not put an equation sign there before mathematics teachers kill me, but let me work underneath it. I can have my volume. Remember, initially, we had a volume of 12. I just want to show you that one. We had a volume of 12. This is the one we got here in this question. We had this one of 12.5. That is the volume that we had. So now we know that the volume of the H2SO4 that was actually added to this base is 12.5. So that we had to calculate it. Whatever answer you got, you're going to carry it over here. I'm going to keep it in centimeters and I'll convert it later. So I've got the 12.5. But what are they saying? They're saying this learner passes endpoint by then actually adding more, which is 5 cubic centimeters. So they are adding more to the sulfuric acid, which means in this volume, I'm going to add the 5 over there. So 12 plus 5 gives me 17, and then I've got 0.5, and this is in cubic centimeters. If you are working with cubic decimeters, I'm going to move my comma 3 times, 1, 2, 3, so that is 0.017. I just want to, if you are getting confused with what I'm saying by moving the comma, 5, let me just write this, dm3. This just is an indication that moving from cubic centimeters to cubic decimeter, I'm dividing it by 1,000. That's all that I'm doing. Now that I've added the sulfuric acid here and I've got my volume, it means that my moles are also going to change. Now I can therefore say the moles of my acid. So now I'm looking for the final moles. Why do I call this final? Because initially I had a volume, I added more to it, so initial, adding, now I've got final, right? So I'm looking for the final moles of the concentration or the moles of the sulfuric acid. So that is then why we call it final. So now the final, now I know that N is equal to CV. Now remember, the concentration of my sulfuric acid, just want to show you back here, we said the concentration is 0.1. I'm still going to use the 0.1. The concentration didn't change. They only added the volume. So the concentration is 0.1. Now, the volume that I'm going to be using is this one. So I'm going to leave it in cubic decimeters, depending on whatever you're working with, 0.175. Now, let's see how many moles do we get there. Okay, that I can't do in my head. So I'm going to say 0.1 multiplied by 0.0175 equal, there we are. So I've got 0.00175, and that is then my moles. 0.00175. Remember, the SI unit for moles is MOL. However, we are still not done. Now that I've got my moles final, I need to see what is then left over. Remember what they told us? We had sulfuric acid, which was initial. We added some of it. We reached endpoint, remember? And now we have final. Now they told us we have in excess. We want to see how much is left over. Remember, we are still busy in a reaction here. Even though we had reached endpoint, we added, but now we need to find out how much is left. If you want to find out how much is left, you now have to separate the two, what you had initially and what you then have final. So that's what we're going to do now. So now I can say that the moles of my acid, remember to always keep the A there, which is left. I can then say for the final moles that I had, minus the initial moles. It's almost like physics where you say final minus initial. So now I know that the final moles that I have is these ones, is 0.00175 minus the initial moles that I had. These are the initial moles that we had, and we got those ones in the previous question where we got them, now I can't remember which slide we worked it out of, but we got it in the previous question, and we got the 0.0215. Those are the ones that we had there. I can't remember which slide we had, but those were my initial moles that I've initially started with, which is 0.00125. Now I want to see how many moles were actually left. So let's calculate that one. So if I've got this one still here on my calculator, I'm going to say minus the initial moles that I had, 0.00125. Let's see what I have here. So now this is what I have now. So this is the moles that are left over. I've got 3 zeros there. I'm going to have 0.005 moles. So that is then what's left. But we are not done because the question asked us to calculate the concentration. Now that I know the moles that are left, this is why this question is for 7 marks. I'm going to just change color so that you see I'm moving to a different dimension. Now that I know the moles that are left, I can then find the concentration, whatever's left. I know that the concentration of the acid is equal to N over V. My concentration is equal to N over V. Now I know my moles, it's the ones I have here, 0,005. Now the volume that I have, remember we had to add all the volumes together. I first then have to say the 25 because that is what we initially had at the beginning of it all. When we are titrating it, that is the volume that we need to take into consideration. So I'm going to say the 25 plus. Then we had the 12.5, which is the volume here, which we found in the previous question when we had, I don't know which slide it is, when we had the unknown one, this one here. That's the volume that we didn't have. So we calculated that one, which is 12.5. And then what did they tell us? That the learner reached end point and then went ahead to actually go add another 5 into it. So this is then the 5 that we are adding. Sure, this was a long question. Then we have 5. Now let's calculate that. So I'm just going to rewrite that 0,005. And at the bottom, let's calculate all of that. So I'm going to have 25 plus 12.5 plus 5 is going to give me, I'm going to get 42.5. I'm just only going to divide it by 1,000 so that I can get it in cubic decimeters. That's the answer that I get. So I'm going to get 0,0425. Now I need to find the concentration. Again, I'm going to need my calculator. Remember, if you have so many big numbers, always put it in brackets. 0.005, close my bracket, go down to the bottom. I'm going to have 0.0425. Let's see what my concentration is. So this is what my concentration is. I'm just going to write it to 2 decimal places. I'm going to move my comma as to 1. So I'm going to have 1 point. The 6 will change the 7, 2, and 8 because I want it in 2 decimal places. Remember, if your comma moves anything to the right, it becomes a negative exponent. So I'm going to have 1.18 times 10 to the negative 2. When we calculate concentration, it is moles per cubic decimeter. So now we have that, or you can actually write it, if you don't want to write it like that, write it as a decimal as 0.0236 if you move your comma from the answer. However, we are still not done. They wanted us to calculate the pH. Now remember, we are working with sulfuric acid. When we are working with acid, we know according to Arrhenius' theory, acids will actually donate an H+, and they will increase the concentration of H3O+ ions in the solution. So now we know the concentration. So this is the concentration that we're going to be working with. Now we need to find the pH. So finding the pH, I'm just going to write the formula here. Let me say pH is equal to negative log, and then the concentration of H3O+. I think, guys, we have done so much for now. I think maybe let's go for an ad break, and when we come back, I'm going to show you guys how we calculate the pH and continue with acids and bases.